Hi guys, I am Zainali from Cricket Academy and I am back with a new video regarding principal plane and stress. This tutorial we would be learning certain important definitions regarding principal plane and stress. Also we would be deriving the equation for the tangential and the normal stress when one side of the plane is subjected to the tensile stress. So let us begin the video by understanding the certain important terms. So first is regarding the resultant stress. So whenever a plane XX on any plane XX is subjected to the stress, then the two components of the stress we can take into consideration. One is the tangential component and another is the normal component. Tangential component, let us suppose that the tangential component is this and the normal component is this. Then the diagonal joining these two tangential and the normal component is defined as a resultant stress, which is denoted by sigma r having the unit Newton per mm square. Hence the resultant stress is nothing but the resultant of the two components of the stresses which are mutually perpendicular, that is tangential and the normal stress. From the figure it is obvious that the resultant stress would be making a certain angle with the normal component as well as the tangential component. The angle with the resultant stress makes with the normal stress is defined by phi. This phi is nothing but the angle of obliquity. Phi is nothing but angle of obliquity. From the figure one can determine that tan phi is equals to opposite upon adjacent, which is given as sigma t divided by sigma n. Therefore phi t is equals to tan inverse of sigma t divided by sigma n. Now next important point is regarding the principal plane. So one can define the principal plane as a plane where the shear stress is 0 and the normal stress is maximum. Hence a plane on which the normal stress is maximum and the shear stress is 0. Such type of the plane is called as a principal plane and the corresponding stress is known as a principal stress. Now there are the two types of the principal stress, that is major principal stress and the minor principal stress. Major principal stress is the maximum value of the principal stress corresponding to the principal plane and the minor principal stress is the stress having the minimum value corresponding to the principal plane. Similarly, principal plane can be of the two types. Principal plane, that one is a major principal plane and another one is a minor principal plane. Major principal plane is a plane which carries the maximum value of the normal stress and a minor principal plane is a plane which carries the minimum value of the normal stress. Now another important point is regarding the zero normal plane. One can define the zero normal plane as a plane on which the normal stress is 0. This is a condition for the zero normal plane. Here there may be a presence of the shear stress, it doesn't mean anything. But the condition should be such that the normal stress should be 0 and for the principal plane normal stress should be maximum and shear stress should be 0. So this is all regarding the important terms. Now let us derive the equation for the normal and the tangential stress when one side of the plane is subjected to the axial tensile stress. So let us consider a plane ABCD having unit thickness which is subjected to the axial tensile stress sigma x. We will be deriving the equation regarding the normal and the tangential stress along the surface BE or plane BE, which is inclined at an angle of theta. Now if we draw this plane BE separately, plane BE which is making an angle of theta, this component is sigma x. Now Instead of the tensile stress, we will be considering the force. We know that stress is equals to force upon area. And for getting the force, we have to multiply the cross section area by the stress. Here the cross section area would be nothing but BC into 1, as it is of unit thickness. Therefore sigma x into BC into 1, or one can write as sigma x into BC. So here we would be also considering the force component only, therefore sigma x into BC. We get the two component as sigma x BC cos theta, and another one we get it as this component, which we get as sigma x BC sin theta. This is a tangential component and this is a normal component. Now we would be applying the equilibrium condition for determining, or one can't say that applying equilibrium condition. We will be simply using the formula that stress is equals to force upon area. Here when we would be deriving the tangential stress, then the component of the force along the tangent, that is the tangential component of the force, is given as sigma x BC sin theta, and the normal component of the force is sigma x BC cos theta for deriving the equation for the normal stress. Hence for sigma t, tangential component of the stress is given by component of the force, which is sigma x BC sin theta divided by cross section area. Cross section area is nothing but BE into 1, as it is of a unit thickness. Now from the figure one can see that BC divided by BE is nothing but a cos theta. Therefore sigma x into cos theta into sin theta, or one can write it as sigma x divided by 2 into sin of 2 theta. This is the expression for the tangential stress. Now for deriving the normal component of the stress, sigma n is equal to normal component of the force divided by cross section area, which is given as sigma x BC cos theta divided by BE into 1, which is given as sigma x into cos theta, which is equal to sigma x into cos square of theta. This is a normal component of the stress and this is the tangential component of the stress. Now for different values of the theta, we get the different values of sigma t as well as sigma n. Here we will be considering the two values, that is theta equals to 0 degree and theta equals to 90 degree. For both these value of theta, the value of the sigma t would be 0. Hence we get the principal stresses, or we get the plane at which the shear stress is 0 but the normal stress is found to be maximum. Now we get the two value of the sigma, and for the two value of the theta, one is sigma x and another is 0 when theta equals to 0 degree and when theta equals to 90 degree. This sigma x is basically sigma 1 and this 0 is basically sigma 2. Sigma 1 is nothing but the major principal stress and sigma 2 is nothing but the minor principal stress. So guys, that's all regarding deriving the expression when only one side of the plane is subjected to the axial tensile stress. If you have any doubt regarding this topic, do comment in the comment section. Do like, share this video and don't forget to subscribe my channel.